Good evening. Welcome to my class. My class is a physics class. The topic is floating and sinking. Now, the tendency of an object to rise to the surface of water or to the higher level of water is what we call floating. And the reverse is true. The tendency of objects to go deeper or to the lower surface of a liquid or air is what we call sinking. Now, a force in a fluid that tends to make these objects feel lighter is what we call upthrust force. Another way, an upthrust force is a force that makes objects tend to feel lighter than they actually are. Now, therefore, we are going to talk about this topic, floating and sinking, and then we'll start with Archimedes' principle. Now, Archimedes' principle states to the weight of this. When a body is either partially or totally immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. Remember, a fluid is either a liquid or a gas. So air is a fluid, water and liquid is a fluid. Therefore, the example says that a stone weighs fluid. Then we'll look at an example and be able to calculate what is this upthrust. Now we say that upthrust force is a force that makes objects feel lighter than they actually are. Now, the actual weight or the apparent weight is actually equal to the actual weight subtract upthrust. Therefore, if we have the actual weight of an object that is immersed in a fluid, you compute the upthrust in that fluid, then you will be able to get the apparent weight for that object. Now, let us look at an example on how we apply this formula. Now, we will look at this example here, and this example will summarize the upthrust force, the apparent weight, and the actual weight as is stated by Archimedes' principle. Now, remember what we said about Archimedes' principle. We said that when a body is either partially or totally immersed in a fluid, it experiences an upthrust equal to the weight of the fluid displaced. Remember, a fluid is either a liquid or a gas. So air is a fluid, water and liquid is a fluid. Therefore, the example says that a stone weighs 2 newtons in air and 1.2 newtons when totally immersed in water. Water is a fluid. Calculate the volume of the stone. Volume of the stone. In other words, the volume of the fluid displaced. The fluid displaced here is water. Therefore, as we have said, it experiences an upthrust. We need to calculate upthrust from here. Upthrust will be given by the actual weight subtract the apparent weight The actual weight is 2 newtons, that's what it weighs in air. Subtract the apparent weight, which is 1.2 newtons. And this one will give us 0.8 newtons. The question asks us to get the volume. We have the weight of the liquid that is displaced. Now, from this weight, how do we go back to get the volume? We are given the acceleration due to gravity as 10 Newton per kilogram. And we know very well that weight is given by mass times the acceleration due to gravity. And therefore, from this relation here, we can be able to get mass. Therefore, we get 0.8 is equals to mass times acceleration due to gravity. Acceleration due to gravity. And therefore, from here, we can divide by 10 both sides. We get mass is equals to 0.08 kilograms. Therefore, the mass of the fluid that is displaced is 0.08 kilograms. Then we ask ourselves, we have mass, then how do we get the volume? We know very well that mass is given by, from the relation density is equals to mass over volume. Then mass, this implies that mass is equals to density times volume. Therefore, using this relation here, we have mass, which is here. Then we need volume of the fluid that is displaced. We know that we have water here. Volume is given by, volume is equals to density. We know the density of water. Then we can get volume here because we have mass. So mass will be given by, we have mass 0.08. This one is equals to density, which is 1000 kilogram per cubic meter, then times the volume. So here we can get the volume by dividing by 1000, Therefore, our volume will be given by 0.00008 cubic meters. So this is the volume of the stone. Now, one thing that we should realize is that the volume of the fluid that is displaced, in this case water, will be equal to the volume of the stone that was put into that liquid. And therefore, the volume of the fluid that is displaced here is 0.00008 cubic meters. Therefore, that is the volume of the stone that was displaced. Now, another question is the density of the stone. Number B is the density of the stone. We have been asked to get the density of the stone in our question number B. How do we get the density of the stone? Density, students, is given by mass over volume. Mass of the stone we had already calculated as 0.08. Mass of the stone will be calculated from the weight of the stone in air, which is actually 2 newtons divided by 10 Newton per kilogram, which will give us 0.2 kilograms, then divided by the volume that we have already calculated here as 0.00008 cubic meters. And if you calculate this one, you will get, this is 2 newtons in air, and therefore, using this relation, weight is equals to mass times acceleration due to gravity, we will divide it by that 2 newtons by 10, and therefore what we will get is 0.2 kilograms. Then, divided by, this is our mass of the stone, divided by the volume of the stone. The volume of the stone is the volume of the liquid, that's water, that was displaced when this stone was immersed in water, which is 0.00008 cubic meters. Therefore, if we divide it here, this one will give us 2 kilograms times, that is 10,000 divided by 8. Therefore, these 2 will go here 4 times, then 4 goes to 125 times, then with these 2 zeros here. Therefore, our density is equals to 2,500 kilogram per cubic meters. Yes, now we come to the end of this part of Archimedes' principle. Our next part is now to look at another law in floating at a sinking called the law of flotation. The law of flotation. Now, welcome to this part. The law of flotation states that a floating object displaces its own weight of the fluid in which it floats. Meaning what? The statement appears ambiguous. The statement appears ambiguous for the teachers of English, but that is how it is. It says that a floating object displaces its own weight of the fluid in which it floats. Now, the weight of the fluid that is displaced is equal to the weight of that floating object. That's what that statement means. And therefore, we are going to look at an example to see how we can apply the law of flotation in our calculations. Yes, that is it. Then let us look at an example. Now, we will look at this example. Our example states that a model ferry boat, 50 centimeters long and 20 centimeters wide, floats in fresh water. If the ferry sinks 6 centimeters as a result of loading, calculate the load on the block. Now, the load on the block. The ferry is floating. Therefore, the amount of water that it will displace will be equal to the weight of this ferry. Because from the law of flotation, a floating object displaces its own weight that is equal to the weight of the fluid. Now, we need to calculate the volume of the water that is displaced here. Now, we know that volume is given by length times width times the height. Now, our length here is 50 centimeters. Change this one into meters. We deal with the right SI unit in meters. Then times 20 divided by 100, then you multiply by 6, the depth that it sank divided by 100. So, this is 5 times 2, which is 10 times 6, gives you 60. 60 divided by 10,000. So, this is 60 divided by 10,000, which gives us 0.0 cubic meters. Now, this is the volume of the liquid that was displaced. Now, let us get the density of the liquid, the weight of the liquid that was displaced. The weight of the liquid that was displaced. Because we know the density of fresh water is 1,000 kilogram per cubic meters. Density is given by mass divided by volume, and therefore volume will be given by density, mass divided by volume, mass divided by density. Volume will be given by mass divided by density. So in this case, what we need is actually mass, so that we use this mass to get the weight. And therefore, we can cross multiply here. Mass will be given by volume times the density. Now, we have the volume as 0.006, then multiplied by the density of fresh water is 1,000 kilogram per cubic meters. This is in cubic meters, and therefore, cubic meter will cancel with cubic meter. We will remain with mass in kilograms. And if we multiply here, this will give us 6 kilograms. Now, we have been asked to get the weight, calculate the load. It means the weight of the load that was put on that model ferry. And we know very well that weight is given by mass times the acceleration due to gravity, which is 10 Newton per kilogram. Therefore, our mass is 6 kilogram multiplied by 10 Newton per kilogram. And therefore, this kilogram will cancel with the kilogram. We remain with 60 newtons. Now, from our law of flotation, the law states that a floating object displaces its own weight of the fluid in which it floats. Now that we put a certain load on the ferry and it sank by 6 centimeters, therefore it displaced an amount of water of this weight, and therefore the load that was put on that model ferry is equivalent to 60 newtons, and this is what we were calculating. And that's the use of the law of flotation. Now, thank you for listening to me. Welcome again for more tips on other areas in physics. This was the law of flotation and Archimedes' principle that was done earlier in the same lesson.